Well, hi there. We're going to have a look at the chain rule today, and that's a very handy little rule in the field of calculus. In fact, it's an Academy Award winner. It's a beauty. So let's have a look. It mystifies a lot of students, but it's very simple. So I'm going to try and help you make it simple so that you get your mind clear on what to do when using the chain rule. So first of all, when do you use the chain rule? Well, the very first step is that you have to identify the class or the type of function that you are differentiating. Okay, now that's what I do anyway in my mind. Okay, there's 4 of them. So it'll be a type 1, a type 2, a type 3 and a type 4. Yes, here comes type 1. It's an x to the n type of function. Now that's the first one that you all learn at school, and it's probably the easiest one to identify. So if you have y equals x to the n, then dy dx is n times x to the n minus 1. For example, y could be x squared, y could be x to the minus a half. It can be a fractional exponent or even a negative fractional exponent. That's fine. The same rule applies, guys. Y equals root x, that's just an x to the half in disguise. Okay, you getting me? That's the type of thing we're talking about for type 1. Now type 2 is, we're getting into the transcendental functions now, as they're called. That's y equals log x, and the derivative for that one is 1 over x. Okay, 1 over x. Type 3 for you and me, this one is an e to the x. Okay, that one's a very neat little function because the derivative of that is just itself. Yes, it's e to the x. Okay, that's why it's such a very special little function. The gradient at any point is the same as the y value of that point. How extraordinary is that? So type 4 and the last but not least are the trig ones, trigonometric ones. So y is sine x, in which case dy dx is cos x. Or we could have y equals cos x, in which case dy dx is minus sine x. Okay, now you've got to identify what class or type of the function that you are looking at to differentiate is. That's the first thing. And then what you do then is, if there's not an x, where you can see an x there in each of those 4 classes, if it's something else, some more complicated thing than just x, that's where you have to use the chain rule, right? That's where you have to use the chain rule. If it's not an x, where there was an x on that previous screen. So you inspect the function. If the form of the function varies from its basic form in the x term, that's where you use the chain rule, guys. That's all you have to know. So the next step is how to use the chain rule. Now that's the one you want to know, isn't it? Well, it's the most fascinating procedure. So what we do is we replace that more complicated, yucky looking term, which is there where the x was supposed to be, and we call it u, a single term to remove the complication, and then we use the chain rule. And the chain rule is like a chain reaction or links in a chain, and you'll be amazed when you see how we use it. Okay, so first of all, identify the class of the function. Is it a type 1, a type 2, a type 3, a type 4? Then think, where does the x go in that function, right? Now, then you look at the function you're trying to differentiate, and if you have got something else besides an x there where that x goes for that class of function, you have to use the chain rule. That's what it's all about. I'm going to give you an example of every one of those 4 classes, and we'll see what we do. Okay? Then I'm going to give you an example of a sort of a chain rule where there's actually more links in the chain. You can actually have infinitely many links in the chain of the chain rule, but in methods you won't get any more than, I think, 3 links in the chain, okay, as a max. Right, class 1, y equals the square root of that horrible looking monstrosity. Now, is it a class 1, or is it a class 2, or is it a class 3, or is it a class 4? Now, come on, you can recognize that is the square root of something, right? Something. You can call the something blob if you like. It's the square root of blob, or it is blob to the half. So that is a class 1. It's something to the half, isn't it? See how you identify the class? It's of the class y equals x to the n, where in this case n would be a half, wouldn't it? So we've got y is something to the half, where the something is definitely not x, is it? It's a monstrosity. However, we're going to whittle it down to size with the beautiful, beautiful chain rule, okay? So what we do is we say, okay, I'm going to let u equal that complicated monster thing. So u equals 2x to the minus 2 plus 3x, and then y becomes u to the half. It's a single symbol again. So we bring it back to the basic appearance of the class that we're in, right? U to the half instead of x to the half, which is a basic form. So we've got y is u to the half. Now, we take the derivative of both of those things, okay? Watch. Therefore, du by dx, or du dx, is going to be 2 times minus 2x to the minus 3 plus 3. Is that fair enough? Right, that's that one done. Now we're going to do y, the derivative of y, but with respect to u, because it's a function of u, the way we've written it, right? Not x. So therefore, what would dy du be? You tell me. Yeah, that's one's cleaned up a bit now. This one would be, yes, it would be a half of u to the minus a half. Now that's all you need to do, guys. Now we're going to chain rule it. And watch how wonderful this is, okay? We say that dy dx is dy, and we split off the dx, okay? We kind of like detach it, and we write it over to the right-hand side of the dy in the numerator, so the dx is in the denominator, and what we do is we form a chain. We form a chain, link them together with the u, du, like that, okay? Just like that. So this is a chain reaction, isn't it? A chain reaction. And these two derivative expressions are kind of like links in a chain, linked by the u, linked by the du part of it, yeah? That's why it's called the chain rule, all right? Now we're just going to continue on our merry way, and we're going to substitute for what we had. Dy du was, and du dx was, and it's that easy, right? So, therefore we had, they're the expressions that we came up with, right? We had them up here, right? There's one of them, and there's the other one there, okay? Right. Now all we've got to do is substitute back for what u was, because remember we invented that term, so you can't have that in the answer. But it was very simple. We just look up to where we defined the silly thing. Here, look. U is 2x to the minus 2 plus 3x, isn't it? So just put that in. So yes, we substitute back for u in terms of x, and we're done, apart from maybe a bit of basic cleaning up. But it's done, isn't it? So I'm going to clean that up and make it look a bit prettier, but your answer is done. That's it, right? So the clean up, I might put that first term there as a 1 over square root thingy, just to make it look a bit prettier. But you don't have to do that. You don't have to do that, right? Your answer is there and done. Mr. Box. Thank you, Mr. Box. There. See, wasn't it beautiful? It's just beautiful. Now, okay, how do you feel about that? Come on, it's pretty simple. So you just got to practice it to get used to it, and you'll be just an absolute snap at it. Here's another one. Class 2 this time. Now, what was that one again? Class 2 was the loggy ones, yeah? How ugly you are, Mr. Log. We're going to make you look much more beautiful in a minute. See, that's this is definitely a class 2 one, where class 2 says y equals log of x to whatever base. We're doing base e, right? Because that's the one we learn in methods. Now, see, what we've got is y equals log of something, where the something is definitely not x. No, I'll say it's not. So, no problem. We're just going to chain rule it. So we call that ugly thing, which is making our head spin, call that u. So there, u equals that thing, and y then becomes log of u, which is the basic form of, it looks like it's basic class 2 form, only we've got a u instead of an x. That's no problem. Now we're going to derive both of those terms. Therefore, du dx is that thing. Do you agree? Yes, and dy du is 1 over u. Very good. Now we're going to use the chain rule, and we're going to have fun doing it. There it goes. There it goes. Right? You got it? Okay, substitute in. What does it equal? Very nice. Very nice. Yes, and now we substitute back for what u was. In fact, it was 2x squared plus 3x plus 8. But it's not causing us any concern anymore. It's given up the fight, and it's ours for the taking in terms of our wonderful victory and our answer, which is there. And thank you, Mr. Box. Like it? You can have it. You can have it, guys. It's that easy, right? Now, what about class 3 for you and me? That was the e to the xy ones, wasn't it? Gurk. Don't worry, guys. You know it. You know by now that's of the class 3 variety, isn't it? That's the type. And we've got e to the something where the something is an x. So we do the same old, okay? We call that complicated thing u, and y equals e to the u. Now we derive both of them, and now that's there. Do you see how I did that? There, that's 2 times minus a half, which is minus 1 of x plus 4, and that just doesn't produce anything, that number there. Got it? Okay, so therefore, and dy du will simply be e to the u, because the derivative of e to the x is e to the x, right? So the derivative of y with respect to u for e to the u would be e to the u. Yes, now we're going to do the chain rule. Here it comes. Good. And it's the same old, same old. Now we substitute in for what we got upstairs there, and we get that. Now we substitute back for what u is, and it is mighty fine. That's what it is. There it goes. There it goes. Looks horrible, doesn't it? But we fixed it, didn't we? We fixed it. There it is. And I'm just cleaning up a bit there. Usually you put those other terms, like when you've got something like that, you usually put that in front of the e. But it doesn't really matter. It's still correct. Perfectly correctamundo, the way you've got it there. Just making it look a bit pretty. Thank you, Mr. Box. That's done, guys. We've done a class 3 now. How are you feeling? All right, come on. We're going to do class 4. Now that's the trig one, isn't it? Right. Okay. So y equals cos of root x. Okay, no problem. This is a class 4 where y, and that's of the type y equals cos x. What we've got is that y equals cos of something where the something is an x. So we are going to chain rule it. So we let u equal root x, the complicated part, and therefore y becomes cos u, and we do the derivatives, don't we? You get that? Good. And yes, derivative of cos is minus sine, right? Cos is minus sine. Derivative of sine is cos, and derivative of cos is minus sine. Okay, so cos has to be a bit different. Now, let's use our chain rule, and we'll have fun. There it goes, and substitute in for what we got up there. There it is. How easy is it? Very, very easy, Mr. Wolfman. And we're going to substitute back for u, aren't we? Very good. What was u again? Oh, yeah, just root x. So there it is. There it is, guys. Smiling at us now instead of frowning. Thank you, and thank you, Mr. Box. See? Now you can do this chain rule. Come on. You can't tell me that you can't do it, because I know you can. Now we're going to do something more complicated. However, don't worry. Now, come on, come on. Have courage. This is chain rule with more than 2 links. In fact, you can do chain rule with many, many links, but you won't get any more than 3, I don't think, in this course. In another subject I teach, you can have more. And it's fun, peeling the onion, let me tell you. Yes, yes, it really is fun. It's fun. Yes, let's go and have one. Ooh, yuck. However, don't worry, you peel the onion. You peel the onion from the outside in. You break it down from the outside inwards like peeling an onion, right? But it doesn't make you cry. It doesn't make you cry. So let's let y equal sine u, right? That's the first thing you do. So I'm saying y equals sine u. That just breaks it down into a single symbol, doesn't it? right? I'm feeling better already. And then I say, well, I'm going to let the U thing equal this monster over here, right? Yes? Now, okay, this one has to be broken down a bit further because it's still not to my liking, but that one's fine. Okay, so therefore the derivative of sine is cos, therefore dy du is cos u. Now let's operate on this beast over here and do another breaking down of that one. So we can say let u equal log of v, right? Now I've got a v happening, where v is this thingy, alright? Now I think I've got it where I want it, don't you? I can go, watch this. Therefore du dv, right, is 1 over v, because the derivative of log is 1 over, right? And then dv dx is that. Now, look, I've got it where I want it now. It's nice and simple, isn't it? Now, are you wondering what we're going to do next? Don't worry, it's chain rule to the rescue. The chain rule, it says that dy dx equals dy du times du dv times dv dx. See the three links in the chain? Isn't it exciting? Oh, come on, it is exciting. And therefore that's cos of u times 1 over v times 2x plus 2. Goodness! And now we've got to substitute back for what the u and the v was, okay, for you and me, and it'll all become clear. But it's not a monster anymore. It's not making us cry. No. There it comes. Watch. Ready? Now, what was u again? Goodness, where are we, u? Where are you, u? Oh, u was this thing. U was that, and what was v? Oh, v was that thing, wasn't it? Yeah? Well, let's go for it. Come on. That's cos of that thing. That's cos of u times 1 over v times dv dx. There it is. Now, I'm not going to clean that up anymore. I just really can't be bothered. But so that's it, guys. That's the three links in a chain rule. So it's really the same procedure, exactly the same procedure as you use for the two links, but you just peel the onion from the outside in. That's what you do, okay? And it just becomes a routine cookbook procedure. But you would need to try a couple to really, unravel them and feel good so the onion doesn't make you cry anymore. There you go, Mr. Box. Thank you, Mr. Box. And how did you like our little expose of the chain rule? It's really a marvellous tool to put in your tool chest of mathematical weapons, okay? So thanks for listening, and we'll see you next time. Bye.